What if the stars are listening? Not with ears, of course, not with intention or awareness. But what if, in their ancient burning, in their slow drift across the cosmic dark, they are connected to us in ways we've only begun to understand? What if the universe isn't just a backdrop to our lives, but an active participant, silent, subtle, yet ever-present? Tonight, as you settle into stillness, look up, even if only in your mind's eye. Picture the night sky stretched above you like a vast, breathing canvas. Stars scattered like grains of sand. Planets wandering their ancient paths. The moon, pale and luminous, hanging in perfect balance. And the sun, hidden now beneath the horizon, still radiating its influence across space that we think of these celestial bodies as distant. Separate. Objects to admire, perhaps, but not to feel. We've learned to see them through the lens of science. Masses of hydrogen and helium, governed by gravity and nuclear fusion. Cold equations. Predictable orbits. But what if that's only half the story? What if the forces reaching us from the heavens, gravity, magnetism, light, radiation, are stronger, stranger, and more intimately woven into our lives than we've ever imagined? What if the moon doesn't just pull the tides, but pulls something within us? What if the sun doesn't just warm the earth, but tunes it, adjusting rhythms, triggering changes, orchestrating life in ways we're only beginning to measure? This isn't mysticism. It's not astrology or ancient superstition. This is the edge of science, the place where data meets mystery, where patterns emerge that we can observe but not yet fully explain. Because the truth is, we are not isolated. We live on a planet that spins through space, bathed in radiation from a star, tugged by the gravity of a moon, and swept through the magnetic fields of distant planets. Every atom in your body was forged in the heart of a dying star. Every breath you take is part of a cycle that began billions of years ago. You are made of the cosmos. And the cosmos, it seems, is still making you so tonight. Let's explore a question that scientists and dreamers have asked for millennia. Asterisk, what if celestial influences are stronger than we know? Asterisk, let's walk between the worlds of evidence and intuition, between measurement and wonder. Let's look at the forces shaping our planet and ask what they might be shaping within us. Because somewhere, in the quiet hum of existence, the heavens are speaking. And we're about to listen. Long before telescopes or satellites, before we understood gravity or the electromagnetic spectrum, humans looked up at the sky and knew something. They didn't know the physics. They couldn't measure wavelengths or calculate orbits. But they sensed a connection, deep, instinctive, undeniable. The sky was not just scenery. It was a map, a calendar, a guide. Picture them. Our ancestors, standing beneath vast, unpolluted skies, watching the stars wheel overhead. No streetlights, no cities, just the Milky Way blazing across the darkness like a river of light. And in that light, they saw patterns. The Babylonians were among the first to formalize it. Around 2000 BCE, they began tracking the movements of planets, those wandering stars that didn't stay fixed like the others. They noticed that when certain planets appeared in certain positions, events on Earth seemed to follow. Harvests succeeded or failed. Rivers flooded. Kings rose or fell. Was it superstition? Perhaps. But it was also observation. Pattern recognition. The same skill that allowed them to predict seasons, navigate deserts, and survive. They created the zodiac, a band of constellations that the sun, moon, and planets traveled through. They believed these celestial movements influenced earthly affairs. And while modern science dismisses astrology as pseudoscience, it's worth noting, the Babylonians also invented mathematics, astronomy, and timekeeping. They weren't fools. They were trying to make sense of a world where cause and effect were not yet understood across the world. Other cultures did the same. In Britain, around 3000 BC, people dragged massive stones across miles of countryside to build Stonehenge. Why? Because they had observed that the sun rose in a specific place on the summer solstice, the longest day of the year. That alignment was important, sacred, even. It marked the turning point of the seasons, the moment when the sun's power began to wane. Knowing that moment meant knowing when to plant, when to harvest, when to prepare for winter. The Mayans built entire cities aligned with celestial events. Their pyramids cast serpent-shaped shadows during the equinoxes. Their calendars tracked Venus with astonishing precision. They believed time itself was cyclical, governed by the movements of the heavens. And in a way, they were right. The seasons are cyclical. The moon's phases do repeat. Time, as we experience it, is deeply tied to the sky. In ancient Egypt, the flooding of the Nile, which brought life to the desert, was predicted by the rising of Sirius, the brightest star in the night sky. When Sirius appeared just before dawn, the floods were coming. This cosmic clock was so reliable that it became the foundation of the Egyptian calendar. Indigenous cultures around the world developed similar systems. The Polynesians navigated thousands of miles of open ocean using only the stars, the waves, and the behavior of birds. The Inuit tracked the movements of constellations to know when to hunt, when to migrate. Aboriginal Australians wove the sky into their dreamtime stories, seeing the land and heavens as mirror images of each other. These weren't primitive guesses. They were sophisticated systems of knowledge, passed down through generations, refined through observation, and proven through survival. And underlying all of it was a belief that the heavens and the earth were not separate, but connected, that the movements above influenced the life below, that we were part of a larger pattern, a cosmic dance we could observe but never fully control. Modern science often looks back at these beliefs with skepticism, and rightly so. Correlation is not causation. The position of Mars doesn't determine your personality. The phase of the moon doesn't dictate your fate. But here's the thing. Just because ancient explanations were wrong doesn't mean the observations were, because as we'll see, the celestial influences they sensed, the pull of the moon, the power of the sun, the rhythms of the planets, are real, measurable, profound. They just work in ways our ancestors couldn't have imagined. Let's start with the obvious. The sun without it. Earth would be a frozen, lifeless rock drifting through the void. The sun is not just a source of light. It's the engine of existence. Every plant, every animal, every breath you take traces back to its energy, but the sun does more than warm us. It regulates us. Consider photosynthesis. Plants capture sunlight and convert it into chemical energy, sugar, stored in their cells. Herbivores eat the plants. Predators eat the herbivores. Every calorie of energy in the food chain originates in the sun's nuclear core, 93 million miles away. We are, quite literally, solar-powered. But it goes deeper. The sun sets our biological clocks. When light enters your eyes in the morning, it triggers a cascade of signals in your brain. The suprachiasmatic nucleus, a cluster of neurons behind your eyes, registers the light and begins adjusting your body. Cortisol rises, waking you. Body temperature increases. Digestion activates. You are, physiologically, turned on by the sun, and when the sun sets, the opposite happens. Darkness signals the pineal gland to release melatonin, a hormone that makes you drowsy, slows your heart rate, and prepares you for sleep. This cycle, this circadian rhythm, is hardwired into nearly every living organism on Earth. From bacteria to blue whales, life follows the sun's rhythm. But the sun's influence doesn't stop at light. Every second, the sun ejects a stream of charged particles into space, a solar wind that rushes outward at 1,000,000 miles per hour. This wind carries the sun's magnetic field with it, creating a vast bubble called the heliosphere that surrounds the entire solar system. Earth sits inside this bubble, protected from cosmic rays and interstellar radiation. But the sun is not constant. It has cycles. Every 11 years, the sun's magnetic field flips. Solar activity peaks, sunspots multiply, solar flares erupt, and massive bursts of energy called coronal mass ejections are hurled into space. When these storms strike Earth, they compress our magnetic field, creating geomagnetic storms. The auroras, those shimmering curtains of light near the poles, are the visible result, but there are invisible effects. 2. Studies have shown that geomagnetic storms can disrupt technology. Satellites fail. Power grids overload. GPS systems glitch. But they may also affect us. Some research suggests that during intense solar storms, hospital admissions for heart attacks and strokes increase. Others have found correlations with migraines, mood disturbances, and even traffic accidents. The mechanisms are still unclear. Maybe it's the disruption of Earth's magnetic field affecting our own bioelectric systems. Maybe it's changes in the atmosphere influencing air pressure and oxygen levels. Or maybe it's something subtler, something we haven't yet learned to measure. The sun also has longer cycles. The Maunder minimum, a period from 1645 to 1715 when sunspot activity nearly vanished, coincided with unusually cold winters across Europe. Rivers froze. Crops failed. It was called the Little Ice Age. Scientists still debate how much the sun contributed versus other factors, but the correlation is striking. And then there's ultraviolet radiation. The sun's UV rays drive the production of vitamin D in our skin, a compound essential for bone health, immune function, and even mood regulation. Low vitamin D levels are linked to depression, fatigue, and weakened immunity. In northern latitudes, where winter sunlight is weak, seasonal affective disorder becomes common, a melancholy that lifts only when the light returns. The sun is not a neutral backdrop. It's an active force, constantly adjusting the conditions of life on Earth. It floods us with energy, sets our internal clocks, shapes our weather, and influences our bodies in ways we're only beginning to understand. And it's just one celestial body, because while the sun commands the day, something else rises when darkness falls. Something quieter, cooler, but no less powerful. The moon doesn't burn. It doesn't generate energy. It's just a cold sphere of rock, smaller than Earth, locked in a slow orbit around us. And yet, it moves oceans. Stand on a beach at night, and you'll see it, the tide rising, water creeping up the sand, pulled by the moon's gravity. Twice a day, every day, the oceans bulge toward the moon. The Earth spins beneath this bulge, and we experience it as high tide. 6 hours later, the tide falls. 6 hours after that, it rises again. This is not a metaphor. This is physics. The moon's gravity reaches across 238,000 miles of space and physically lifts the water, but it's not just the oceans. The moon's gravity also pulls on the land, the solid crust of the Earth. The ground beneath your feet rises and falls by about a foot twice a day. You don't feel it because everything around you moves together, but it's there. The moon is flexing the planet, and life has learned to listen. Coral reefs, for example, time their spawning to the lunar cycle. Once a year, on a specific night, usually a few days after the full moon, millions of coral polyps release eggs and sperm into the water simultaneously. This mass spawning is one of nature's most spectacular events, and it's triggered by the moon's phase combined with water temperature and day length. Sea turtles crawl onto beaches to lay eggs during high tides around the full or new moon. The higher water helps them reach the sand more easily. When the eggs hatch weeks later, the baby turtles emerge at night, using the moon's reflection on the water to guide them to the sea. Oysters open and close their shells in rhythm with the tides, filtering nutrients from the water. Even when moved to a lab far from the ocean, they continue the pattern, proof that the behavior is tied not to water, but to the moon itself. Certain species of fish, crabs, and worms synchronize their mating cycles with lunar phases. Marine worms called palolo worms swarm in massive numbers during the last quarter moon in October and November, their bodies breaking apart to release eggs and sperm. Indigenous peoples in the Pacific have harvested them for centuries, knowing exactly when they'll appear. Even microscopic plankton migrate vertically through the ocean in response to moonlight, rising toward the surface at night and sinking during the day. This daily migration, the largest movement of biomass on the planet, is influenced by the moon's brightness. And then there's us. Humans have long believed the moon affects behavior. The word lunacy comes from luna, the Latin word for moon. Folklore claims that the full moon causes madness, increases crime, and triggers bizarre behavior. Emergency room workers and police officers often swear their busiest nights are full moons. But when scientists study the data, the evidence is mixed. Some studies find no correlation. Others detect weak but statistically significant patterns. Hospital admissions for certain conditions do seem to cluster around the full moon. Sleep studies show people sleep slightly less and more restlessly during full moons, even in windowless rooms where they can't see the light. Why? One theory involves melatonin. Even small amounts of light can suppress melatonin production. Before artificial lighting, the full moon was the brightest source of nighttime illumination. Our ancestors would have been exposed to its light, potentially disrupting sleep. Perhaps our bodies still respond to that ancient rhythm, even when we can't consciously perceive it. Another theory involves the moon's gravitational pull. If the moon can move entire oceans, could it affect the water inside our bodies? Humans are about 60% water. Our brains are 73% water. Could the moon's gravity create subtle pressure changes in our cells, our cerebrospinal fluid, our neurochemistry? The science is inconclusive. The effects, if they exist, are small. But small doesn't mean insignificant, because the moon is part of a larger pattern, a web of celestial influences that overlap, interact, and resonate. And when we zoom out, when we look at the solar system as a whole, something even more intriguing emerges. The planets are far away, much farther than the moon. Jupiter, the largest, is over 400 million miles from Earth at its closest. Its gravity is immense, but at that distance, its pull on us is negligible. Far weaker than the tug of a passing sea. So why consider planetary influences at all? Because the universe doesn't work in isolation. Everything is connected, not through mystical energy, but through the fundamental forces of physics: gravity, magnetism, radiation. And while individual planetary effects on Earth are tiny, they're not zero. And in a complex system, like a climate, an ecosystem, or a human body, tiny influences can amplify, resonate, and cascade in unexpected ways. Take Jupiter. For example, its massive gravity acts as a cosmic vacuum cleaner, pulling asteroids and comets away from the inner solar system. Without Jupiter, Earth would be bombarded by far more impacts. Some scientists believe that without Jupiter's protective influence, complex life might never have evolved here. We owe our existence, in part, to a planet we barely notice. But Jupiter does more. Its gravity tugs on the sun, causing the sun itself to wobble slightly. This wobble affects the distribution of sunlight across the solar system, not by much, but measurably. And it influences the orbits of other planets, including Earth, in subtle ways that accumulate over millennia. Then there's Earth's magnetic field, our invisible shield against solar radiation. This field is generated by the churning of molten iron in Earth's core. But it's not perfectly stable. It fluctuates. It weakens and strengthens. And every few 100,000 years, it flips. North becomes south. South becomes north. What causes these fluctuations? Internal dynamics, yes, but also external influences. The gravitational pulls of the moon, sun, and planets create tidal forces not just in the oceans, but in the molten interior of the Earth. These forces may contribute to the convection patterns that generate the magnetic field. And when the magnetic field weakens during a reversal, for example, more cosmic radiation reaches the surface, cloud cover may increase, climate may shift, evolution may accelerate as mutation rates rise. This isn't speculation. It's geology. Scientists have found correlations between magnetic reversals and mass extinctions, climate shifts, and evolutionary leaps. Now consider orbital resonance, the way planets' orbits align in mathematical ratios. Neptune and Pluto, for example, orbit in a 3:2 resonance. For every 3 orbits Neptune makes, Pluto makes 2. This synchronization stabilizes Pluto's orbit, preventing it from ever colliding with Neptune despite crossing its path. Similar resonances exist throughout the solar system. And while their direct effects on Earth are subtle, they influence the distribution of asteroids, the behavior of the Kuiper Belt, and the long-term stability of the entire system. Then there are the Milankovitch cycles, variations in Earth's orbit and axial tilt caused by the gravitational influences of Jupiter and Saturn. Over tens of thousands of years, Earth's orbit becomes more or less elliptical. Its axial tilt oscillates between 22 and 25 degrees. These tiny changes alter how much sunlight reaches different parts of the planet, driving ice ages and warm periods. The planets don't dictate Earth's climate, but they modulate it. They fine-tune the conditions under which life evolves. And beyond the planets, there's the galaxy itself. The solar system orbits the center of the Milky Way, completing one galactic year every 225 million years. As we move through the galaxy, we pass through different regions, some denser with gas and dust, some flooded with cosmic rays from nearby supernovae. These changes influence Earth's climate, cloud formation, and even the rate of genetic mutations that we are not isolated. We are not static. We are moving through a cosmos that is alive with forces, gravity, magnetism, radiation, all interacting, all influencing, all creating the conditions for existence. And deep within that cosmic orchestra, there's a rhythm, a resonance, a music we're only beginning to hear. Everything vibrates, atoms vibrate, molecules vibrate, your heart vibrates with every beat. The earth itself vibrates, ringing like a bell when struck by earthquakes, humming with a constant, low-frequency oscillation caused by ocean waves, wind, and atmospheric pressure. This hum is called the Schumann resonance. It's a standing wave of electromagnetic energy trapped between the Earth's surface and the ionosphere, resonating at about 7.83 Hz. It's the planet's heartbeat. And remarkably, it's close to the frequency of alpha brain waves, the waves your brain produces when you're relaxed, awake, but not focused. Is this a coincidence? Or did life evolve to resonate with the planet itself? The concept of resonance is simple. When two systems vibrate at similar frequencies, they can synchronize. Push a child on a swing at the right rhythm, and they'll go higher and higher. Push at the wrong rhythm, and you'll dampen the motion. Resonance is everywhere. Musical instruments resonate. Bridges can resonate, sometimes catastrophically, as with the Tacoma Narrows Bridge, which collapsed in 1940 when wind caused it to vibrate at its natural frequency. Even the universe itself resonates. The cosmic microwave background, the afterglow of the Big Bang, shows patterns of density fluctuations that arose from sound waves in the early universe. Could celestial bodies resonate with life on Earth? Consider circadian rhythms. Your body's internal clock runs at about 24 hours, slightly longer, actually, which is why you need sunlight to reset it each day. But that rhythm is deeply embedded. Even bacteria have circadian-like cycles. The entire tree of life pulses to the day-night rhythm set by Earth's rotation. Now consider circannual rhythms, yearly cycles. Birds migrate. Bears hibernate. Deer mate in the fall. These cycles are tuned to Earth's orbit around the sun, 365 days, with seasonal variations in sunlight and circulunar rhythms, monthly cycles. Corals spawn. Tides rise and fall. Some women's menstrual cycles approximate the lunar month. Though the science is debated, these aren't isolated phenomena. They're evidence of a deeper principle. Life synchronizes with the rhythms of the cosmos. But what if there are rhythms we don't yet recognize? Researchers have found that Earth's magnetic field fluctuates with the solar cycle, 11 years. Some migratory birds use the magnetic field to navigate. Could they be affected by these fluctuations? Could other animals? Could we? There's also evidence that the planet's gravitational influences create subtle periodicities in Earth's systems. The Chandler wobble, a small oscillation in Earth's axis, has a period of about 433 days, influenced by the distribution of mass in the oceans and atmosphere. Some scientists suggest planetary alignments may contribute. And then there's the question of consciousness itself. Eastern philosophies have long spoken of the body's energy centers, chakras, resonating at specific frequencies. While dismissed by mainstream science, modern research into bioelectricity is revealing that cells communicate through electrical signals, that the nervous system operates through oscillating waves, and that the brain itself is a symphony of rhythms, delta, theta, alpha, beta, gamma, each associated with different states of consciousness. Could these internal rhythms resonate with external ones? Could the Schumann resonance influence brain activity? Could solar activity affect neurochemistry? The evidence is preliminary, intriguing, but not yet conclusive. What is clear is this: the universe is not silent. It hums, it pulses, it vibrates, and life, embedded within it, hums along. That we are not observers of the cosmos. We are instruments within it, and the music it plays moves through us, whether we hear it or not. But what happens when the music changes? Throughout Earth's history, celestial rhythms have shifted, sometimes gradually, sometimes catastrophically. And when they do, life transforms. Consider the ice ages. Over the past 2 million years, Earth has cycled between deep freezes and warm interglacials. These cycles are driven by the Milankovitch cycles, tiny changes in Earth's orbit and axial tilt caused by planetary gravitational influences. The changes are small, a few degrees of tilt, a slightly more elliptical orbit, but the effects are enormous. When the tilt decreases, summers become cooler. Snow that falls in winter doesn't fully melt. It accumulates, year after year, forming glaciers. Ice sheets spread across continents. Sea levels drop. Ecosystems shift. Species migrate or go extinct. And then, slowly, the tilt increases again. Summer's warm. Ice melts. Forests return. The world breathes. Humans evolved during these cycles. Our ancestors survived ice ages, adapted to shifting climates, and thrived. But we also remember, deep in our mythology, there are stories of great floods, long winters, and worlds transformed. Perhaps these are echoes of climatic shifts our ancestors witnessed. Now imagine if the celestial rhythms shifted more dramatically. What if the sun's output increased by just a few percent? The earth would warm. Ice caps would melt. Sea levels would rise. Weather patterns would destabilize. Droughts and floods would become more common. Ecosystems would collapse and reform. What if the sun's output decreased? Another ice age. But this time, with billions of humans dependent on agriculture, the consequences would be catastrophic. What if the moon drifted closer? Tides would become massive, waves swallowing coastlines, reshaping continents. Days would slow as the moon's gravity braked Earth's rotation. The climate would destabilize. What if the moon drifted farther away, faster? Tides would weaken. Earth's axial tilt, currently stabilized by the moon, would begin to wobble. Seasons would become chaotic. Life would struggle to adapt. What if Earth's magnetic field weakened, or reversed, as it has many times before? More cosmic radiation would reach the surface. Mutation rates would increase. Evolution would accelerate. But so would cancer rates, crop failures, and health crises. These aren't fantasies. They're scenarios rooted in physics. And they've happened before. Magnetic field reversals occur every few 100,000 years. The last one was 780,000 years ago. We're overdue. The field is already weakening, particularly over the South Atlantic. Some scientists believe a reversal may be starting. Solar cycles vary in intensity. The sun's output can fluctuate by a fraction of a percent, enough to influence climate. And while the variations are small, they're not trivial. Asteroid impacts, rare but devastating, are triggered by orbital perturbations in the asteroid belt, often caused by Jupiter's gravity. The impact that killed the dinosaurs 66 million years ago was a cosmic accident. But it was an accident shaped by celestial mechanics. The point is this: we live in a dynamic system. The celestial dance is not static. It shifts. It evolves. And when it does, everything on Earth shifts with it. But here's the deeper question. Do these shifts affect not just our environment, but us? Our biology, our psychology, our consciousness? Because if celestial influences are real, if they're stronger than we know, then they're not just shaping the planet. They're shaping us that we are creatures of rhythm. Your heart beats in a rhythm. Your lungs breathe in a rhythm. Your brain fires in rhythmic waves. Even your cells operate on cycles, dividing, repairing, communicating, and many of those rhythms are tuned to the cosmos. Your circadian rhythm, your sleep-wake cycle, is driven by the sun. Light enters your eyes, signals your brain, and adjusts a network of biological clocks throughout your body. Every organ, every tissue, every cell has its own clock, all synchronized to the master clock in your brain. But what if you removed the sun? What if you lived in a cave with no external cues? Scientists have done this experiment. Volunteers lived in isolation, without clocks, sunlight, or any indication of time. And their circadian rhythms drifted, lengthening to about 25 hours. Without the sun to reset them, they slowly fell out of sync with the outside world. This proves something profound. The sun doesn't just inform our rhythms. It entrains them. We need it. We're built to follow it. And it's not just daily rhythms. Seasonal rhythms, circannual rhythms, are just as powerful. In northern latitudes, where winter daylight is scarce, people report feeling more tired, more depressed, more withdrawn. This is seasonal affective disorder, and it's driven by reduced sunlight. The lack of light disrupts melatonin and serotonin production, affecting mood and energy. Even in milder climates, people feel the shift. Spring brings energy, optimism, renewal. Fall brings reflection, introspection, sometimes melancholy. These aren't just cultural associations. They're biological responses to changing light, And then there's the moon. Studies on sleep consistently find that people sleep slightly less during a full moon, about 20 minutes less on average. They also report more restless sleep, more vivid dreams. And this happens even when they can't see the moon, even in urban environments flooded with artificial light. Why? One theory is evolutionary. Our ancestors lived by moonlight. The full moon was the brightest nighttime light source, offering opportunities to hunt, gather, socialize. Perhaps our bodies still respond to that ancient signal, becoming more alert, more wakeful when the moon is full. Another theory involves the moon's gravitational pull. If it can move oceans, perhaps it creates subtle pressure changes in the fluids of our bodies: cerebrospinal fluid, blood, interstitial fluid. These changes might influence brain activity, hormone levels, mood. The evidence is still emerging, but it suggests something important. We are not insulated from the cosmos. We are part of it, and yet, modern life has tried to sever that connection that we live indoors. We light our homes with artificial light, bright at night, dim during the day. We ignore the sun's rhythm, staying awake long after sunset, sleeping through sunrise. We've created an eternal twilight, disconnected from the sky, and we're paying for it. Rates of insomnia, depression, and anxiety are rising. Circadian rhythm disorders are becoming common. Shift workers, who live against their natural rhythms, suffer higher rates of heart disease, diabetes, and cancer. We've gained control over our environment, but we've lost our connection to the rhythms that shaped us. The good news? The connection isn't severed. It's just dormant. Step outside on a clear night. Look up. Let your eyes adjust. The stars will appear, faint at first, then brighter. The moon will glow, and somewhere, deep in your cells, something will respond. Not consciously, not dramatically, but quietly, like an old song you forgot you knew, because you are made of the cosmos. And the cosmos remembers there's a place where science and intuition meet. Science deals in measurements. Data, reproducibility. If something can't be quantified, it's difficult to study. And if it can't be studied, it's easy to dismiss. But intuition operates differently. It senses patterns before they can be articulated. It feels connections before they can be proven. And throughout history, intuition has often been right, not in the details, but in the essence. Ancient peoples intuited that the heavens influenced the earth. They were right. They just didn't know the mechanisms. Indigenous cultures intuited that everything is connected, that land, sky, water, and life are woven into a single fabric. They were right. Ecology and systems theory have confirmed it. Mystics have long spoken of energy fields, vibrations, and cosmic consciousness. And while their language differs from science, modern physics is revealing a universe that is fundamentally made of energy and vibration. Quantum field theory describes particles as excitations in underlying fields. String theory proposes that everything is made of vibrating strings of energy. Could there be truth hidden in ancient wisdom? Could the language of spirit and the language of science be describing the same reality from different angles? Consider this. Consciousness remains one of science's greatest mysteries. We don't know what it is. We don't know how it arises. We can measure brain activity, but we can't explain why there's an experience attached to it, a sense of I, a feeling of awareness. Some scientists propose that consciousness is an emergent property of complex systems. Others suggest it's fundamental, woven into the fabric of the universe itself. That if consciousness is fundamental, then perhaps it's not confined to brains. Perhaps it's a field, like gravity or electromagnetism, that permeates everything. And perhaps, in ways we don't yet understand, consciousness resonates with the cosmos. This isn't mysticism. It's a hypothesis, admittedly speculative, but taken seriously by some physicists and philosophers, and it would explain certain experiences that people report: feeling connected to nature, sensing the presence of something larger, experiencing synchronicities that seem too meaningful to be random. Maybe these experiences aren't illusions. Maybe they're glimpses of a deeper pattern, a resonance between the consciousness within us and the patterns around us. Or maybe not. Maybe consciousness is entirely local, confined to brains, and the sense of cosmic connection is just a beautiful illusion. But does it matter? Because whether the connection is literal or metaphorical, it changes how we live. When you see yourself as part of the cosmos, not separate, but woven in, you move differently through the world. You feel humility, responsibility, awe, and that feeling, whether grounded in physics or poetry, is real. It shapes behavior. It deepens meaning. It opens you to wondered. So perhaps the question isn't whether celestial influences are scientific or spiritual. Perhaps the question is, can we hold both perspectives at once? Can we measure the moon's gravity and still feel its mystery? Can we understand circadian biology and still marvel at the sunrise? Because the universe doesn't demand that we choose. It invites us to integrate, to see the data and the wonder, the mechanism and the meaning. And in that integration, something beautiful happens. The cosmos stops being a cold, indifferent machine. It becomes a living presence, breathing, pulsing, resonating, and you become part of that breath. And now, we return to where we began, to stillness, to the quiet beneath the stars that you've traveled far tonight, through time, through space, through the forces that shape existence. You've seen the sun's warmth, the moon's pull, the planet's subtle dance. You've felt the resonance that hums through everything. And now, it's time to rest, because the cosmos is not a place of constant action. It's a place of breath, expansion and contraction, light and dark, motion and stillness. Stars are born in clouds of gas, burn for billions of years, and then fade, returning their matter to space, where new stars will form. Planets orbit, but also drift. Tides rise and fall. Seasons turn. Life blooms and withers and blooms again. Everything inhales. Everything exhales. And you? You are part of that breath. Every atom in your body was forged in the heart of a dying star. The oxygen you breathe was created billions of years ago in supernova explosions that scattered elements across the galaxy. The water in your cells cycled through ancient oceans, through rain and rivers, through countless living things before reaching you. You are not separate from the cosmos. You are the cosmos, localized, condensed, aware, and just as the universe breathes, so do you. Inhale. Feel your chest expand, the air filling your lungs, the oxygen entering your blood, carried to every cell. Exhale. Feel your body soften, the tension release, the breath returning to the world. This rhythm, this simple, ancient rhythm, connects you to everything. To the tides breathing in and out under the moon's pull, to the sun's light streaming across space, to the slow rotation of the earth beneath you. You are held by forces you cannot see, guided by rhythms you barely perceive. And yet, they are always there, constant, patient, eternal. So as you drift now towards sleep, let yourself trust that rhythm. Let the day's worries fall away. Let the questions rest, because the cosmos will continue without your vigilance. The sun will rise. The moon will wax and wane. The stars will wheel overhead, just as they have for billions of years. And you? You will rest. You will dream. And when you wake, the dance will still be there, waiting, inviting, eternal. The celestial influences are real. They move through you, around you, within you. Not as fate, not as force, but as presence, as connection. You are not alone. You are part of a vast, living harmony. And in that harmony, there is peace. So rest now. Let the cosmic breath carry you. Let the stars watch over you. Let the universe hold you in its ancient, infinite rhythm. You are safe. You are held. You are home.